What's up? It's the chosen one. He's back, the biggest choice. Oh, and I made a new folder, bro. Stop playing. All right, so check this out, right? Version 1, this was the immediate mode. I mean, it's full of 493 error. I mean, they're all errors because it's like these functions don't exist. I just don't use this header file anyway, so it's like not compiled. So I guess it says it's a warning and whatever. You know what I mean? You would render a button like this. It would just, immediate mode rendering. Whatever. I had some like gigantic context thing. This concept of themes. Whatever. I had this like pretty simple like layout concept. Had a theme. And then I guess that was my draw. I guess that's it. That's all I had for drawing. It was pretty rudimentary. It got the job done. Version 2 just blew up in terms of complexity. It's a bunch of random shit is in here. But it was the start of something new. It was the start of, it was non-immediate mode. It was sort of like, okay, now we have the idea of this, we construct this like layout tree and then we solve constraints. We actually run an actual constraint solver rather than, doing like laying it out real time. And then yeah, but it got a little messy at the end. There's a bunch of stuff in a bunch of different files. It's kind of all over the place. Now version 3 is sort of like what we've been working on for the past few days. I think I've done all of version 3. I'm just gonna get one tab because these files aren't huge anymore. I mean, this one kind of is, but like we have a constraint solver. This is our constraint solver. Pretty simple, sort of like we have the concept of like our element buffer, which is like sort of our layout tree. You can write to it, and then the idea. And then, all right, let me just go through the rest. We have like our event system, which I actually worked on off camera at the car dealership this morning. Expression. I mean, I want to rename this. It's weird because I did opt for like operation for like sort of like push this on, push these things on, and then when you hit something like this, but like maybe these are all operate like. I don't want to distinguish from all of these things. Like I don't want to be like, oh well, API wise we're gonna accept constraint : width, constraint : height, operation : add, or whatever. You know what I mean? It's just gonna be like, I don't know. I just need to cut like maybe this just becomes like EXPR or something like that. But I don't mind op. I don't know. It's in expression.hpp, so I'm conflicted, right? And then we've got this stuff. Turns out I don't think we needed that, because we got this whole AST thing going on here. There's abstract syntax tree for expressions. And then yeah, I'm thinking about just combining these into one thing, which is literally just using these as this stuff too. And then quad tree, which is not really implemented, but this will be the API. And I don't know. Quad trees kind of confuse me. I mean, like theoretically I get them, but it seems confusing to me. So, and I don't know. Maybe there's some other sort of like spatial data structure that makes more sense. But whatever. It's pretty simple. I think we're gonna end up having style, and then I want to have style. I want to have like context, which is just gonna be sort of like a large context object, and then I'm going to have like api.hpp, and that's going to be all the stuff that like you should just have to include API and you should be able to use it. So it's gonna sort of provide you with like the API to like build the layout and stuff like that. So I'm still working on actually like separating this file out into multiple different files. So yeah, so I think this goes into this goes into event. But yeah, it feels good to like be wrapping up an early version of V3. You know, it looks like V1 in terms of number of files, but it kind of accomplishes like I had these like crazy like builder things, like all these like macros and stuff. Like we don't even have element classes. Granted, I haven't done text yet, so that's something I forgot to think about. But like, I feel a lot more fluid with this design. I think this better expresses the sort of like atomic structures of the UI framework, which is a box that has constraints. That's what everything like the concept, even the concept of an element is not really like, okay, here's an element object that needs to exist. So I'm really trying to like move away from like the thought process of, oh, I need this, therefore let me create this struct that represents this. Like, yes, we have an element struct, but what's in it? Like, not, can you render it just with this? Like, probably not. You know what I mean? I mean, well, actually, the point is, you know, this doesn't handle layout. This is like sort of like an element handle, really. Maybe I should rename it that. To do consider rename. How do I spell naming? Oh, there we go. Element handle. Okay. I'll consider it. I'll think about it. Okay, so we have our event types. We have, this might need to be a uint 16 because we ran out of options, and there might be another event that we want to like drag or something. In fact, I'm just gonna do that. Uint 16t, and then this also is a 16. This is a 16. This is a 16. This is a 16. Yeah, I need to look back at this, because here's the other thing. Here's the other sort of like design thing. It's sort of like this sort of stuff just needs an event context. So it just needs, we need a callback buffer, or like event handler buffer. I need to be okay with long names. We need an event handler buffer. I'm getting a call. What the hell? Oh, I did not get a call. Okay. Forgive me. Forgive me. Okay. Oh, say. You know what I mean? I do not know this one. I do not know this one. Okay. I can't deal with anything that's happening on my phone right now. That is Okay. Sorry. I'm back. I'm locked in. I'm the chosen one. The chosen one is back. Okay. So basically, I kind of want to have something like. What else do we use UI for? Oh, we need an element buffer. What type? Do we just use back, or should we use something like element? Because elements just like, because I'm kind of thinking it's like we have these like this idea of like data files and then like function files, and like data files like just store types, and then function files just store functions, and that way you don't include a bunch of functionality that you don't need, and you're only like maybe this is the way to do it. So what we can do is we can say event handler context CTX. Probably just take a const ref, and then we can say I mean this we could even take a ref, and then CTX dot boom, CTX dot and the reason for this is that this way all of these like separate files don't have to care about how we're actually storing stuff. All you need to do is pass in the information to this API, but this API does not care. All this implies is that you have to set this up somewhere else. I am not, because I'm taking a reference. It's like you can't even like default initialize this object. You have to pass in values. You know, so yeah. Sorry, my car. I gotta keep it on my phone in case some news about my car happens. I'm hoping everything is okay. You know, love my car. Want everything to be okay. Okay, so back to work. Back to work. Okay, we already took that argument. CTX dot. And then we don't need to do this. We could just do CTX dot element, because we're talking about an element. It doesn't. I mean, theoretically, it means the last element, but I don't know. I'm just gonna do it this way. I guess this makes more. Oh wait, this we need CTX dot event handler buffer, CTX dot element. I don't know. It's more flexible. Maybe it makes you mess up a little bit more, but whatever. God is good. This can just be this sort of this is a little confusing because it's like we want everything to go through this like we could say something like read at, take a custom offset, or we could say temp offset equals temp offset. Don't make that const. Temp offset. Don't do that. So we could say like, if we want to read without, if we know where we want to read and we don't want to like start a whole process of reading and like pushing forward any sort of offset, well, maybe read should call read at, and read at returns or updates. Maybe it returns a new offset. That might be the better way to do this. So it's like, so we could say something like, well, no, it's not that much logic. It's really not. We can just do return. Like this is not worth making a function, and now we just have 2 lines. Like I think that's fine. I'm not gonna like really deliberate over this right now. Because these arguments are long, I'm gonna do that. So handle event means actually like call the function. Write event means events handled equals ctx dot event handler buffer dot reader dot read at stood uint 16t, and then we need the temp offset, which is ctx dot element dot event handler index. This, does read always return a pointer? No. This should be right, yeah, because we're dereferencing. That should theoretically work. We can test this. I tested this event system already when it was all in one file, and it did work. So that's good. Okay, so events handled, we can, I'm gonna comment that out just in case, but that's really what it should be. I'll put this like up here. I kind of need the code to always look good. ctx dot event handler buffer, ctx dot event handler buffer writer dot write. Okay. This I'm not mad at. So, oh, start and pop. Okay. So now we need to basically, so we have sort of these systems, right? We have these systems, like this is sort of like a system, event system, right? Like the idea is like we have systems, like the hierarchy is like we have basic types, data structures. That's not actually basic types, data structures, algorithms. This is all sort of like, you know, these things are generic, and this is like, you know, just types. All right, so that goes down into does that then immediately get used by like system relating to 1 or 2 types? and then that gets used by, that gets inherited. Like, this gets called somewhere. So this gets called from, like, top level API. Is that the right way to think about this? Let's use that for now. Okay, so we have Bright. This is a system. This is a sim system. This is a type. This is a system. This context should really just have pointers to stuff. I think. But this, I don't know. We'll see. We'll see when we get back to here. Sorry, are there any other errors in these files? No. Okay. So it's just we need to get the rest of this file cleaned up. Okay. So UI context should be something like, this should really be like context.hpp, and then it should be like, I'm gonna put that here, pragma once, namespace tie UI v3, put that there. We'll call it UI context for now. Well, I'll just call it context, because this is like the main context for the API. This is responsible for allocating memory, I think. So where solve context, we include constraint solver. We have include element buffer writers, element buffer writer. So you include these systems. Why is this? Does element buffer writer not care what an element is? It actually might not. This is why this should probably really be called element handle, because it sort of doesn't make sense that element wouldn't be included in element buffer writer, but element handle is sort of like a different type that, you know, we may not need it for the writer. Okay. Quad tree, which is sort of like a cross between a data structure. I mean, it is a data structure, but it's like a data structure, but then it has like our specific stuff in it, sort of. It might not belong even in this API. So quad tree is going to be a little bit different. Quad tree is like a data structure that maybe gets promoted to here, maybe doesn't. We'll see. Okay, so context gets initialized, and what's the problem? Okay. Everything has a default value. Everything gets initialized. Great. I'm gonna do something like, I usually have like a util include, and the reason for it is like just to throw stuff. Like, I'm not gonna make a time function or time file because I'm not doing that much with time, right? But I might throw some other sort of like common things in here that don't really fit. Like, this is sort of a staging, this is sort of like an intermediate file that like ideally wouldn't exist, but whatever. Okay. I think we don't need that. Now I think this is our last file. API. So API is going to be our sort of like this faces the user or the client or whatever. And for now, this is where we're going to store our main context. So we're gonna say include context.hpp. We don't need a hashtag there. Okay. All right. So this should be the only file where we use this like UI thing. API shouldn't be included anywhere in this. And it isn't because we just created it. There's two issues. Write event. We can include event. Okay, right. So we're gonna need to create an event context. So we could say event context has UI dot callback buffer, comma, UI dot lm buffer dot back. There we go. Okay. Okay, so that's pretty much that. We can get rid of, I'm gonna say let's comment everything out in this file. Okay, so everything is theoretically sorted. Now let's make sure we can get away with this. Let's say, maybe let's remove that. Let's say instead of constraint solve it, we're gonna say tie paradigm v3 API. Okay. Okay. We're gonna want to redefine. Actually, let's say tie UI. Let's make ourselves write this out so that we don't have to keep using. We can include that for now, but that's like a lot of this stuff. See, handle event. This is gonna be. See, this is gonna be called with. See, now here's where it's sort of like. I mean, I guess there's not. I guess this isn't a bad thing to do, right? If we say if we want to create as little stuff on the fly, if we say this is not element, this is stood vector element. If this is what we need to run these functions, and we take the context. And we say like auto lm equals ctx element back, and we say like write event writes like this is supposed to be called sequentially, right? Like I mean, it's even saying like this really only gets called like let's put the brakes on this context thing. Let's say handle event because we only really need a context object if we have a bunch of like random stuff. So what we could really say is like buffer event handler buffer, and we say event, or we just get rid of ctx, like, let's just start off, instead of like trying to like shoehorn everything into like, okay, we need like a context object, we could literally just say, well, I'll keep it there for now, but this thing might change, because there is something to be said where it's like, okay, if we look at this test, a lot of this stuff needs to go into paradigm as well. So we need to look at all these different steps. Now, if we say lm state equals lm prev, so this is like the element system. This is like, or this is, well, no, this is the event handler system. Because we're not actually changing. Hey, why are you doing this? Can you, bro? This cat, she's just like on about something. Like, stop digging through. Like, no. Again, it's not for you. Go do something else. Oh my gosh, I'm just trying to dig through all the stuff we gotta send back. It's a sham, I tell you. Okay. Okay, this is really part of the event system. This is event handling. Or this is event handling. Where's that? Yeah, this loop right here is event handling. So this should be something like, we have handle events, or this should be like handle events. And we get past a buffer, event handler, buffer, and a stood vector element. LM buffer. And I don't think we are changing anything in that. I actually don't think we're changing anything in anything. So let's start with const. Let's say, let's go to UI, get rid of UI. Looks good. This should be event handler buffer. Dot reader, I guess maybe that can't be const for some reason. That's a me thing. That's a different me thing. That's a different me who did that. Handle event takes what? Event handler buffer. Event handler buffer. And see, okay, this is sort of like, this is why it's sort of like you might be like, James, okay, well, why don't you just create like a struct event handler, or you know, whatever, and then just like initialize it with all the fields that you need? Well, because that's cheating. That's not good design. Just because it's easy to instantiate and requires you to like, if you're doing something, like, imagine you're at the doctor's or whatever, and they're like, fill out these 10 forms. We might need some of them. We don't know. Like, wouldn't you rather like fill some stuff out like only if you had to? Like, or like, you know, bring less stuff to go do something if you don't need everything? Like, I know these are like real life examples, and like we're, you know, we write code, so we don't do any of that, you know, but I think this is, you look at this function and you're like, okay, I need specifically this buffer, because we're going to actually, what we're going to do is we're going to look for the event that we want to call. We know it's there. We're going to find it. We're going to call it. Okay. Instead of saying, okay, we're going to take this context, and it's just like, well, what do we need from the context? Do we just need one field in this case? Yeah, we do. The context is 2 fields. We can't just like use 2 arguments. That's not that hard, right? Let's just do that. I think the solve thing's different because we were starting to do like 6 or 7 different arguments, you know. So whatever. Okay. Make some context like solver context. Wrong. Okay, canceled. Canceled that. And we'll probably get rid of this context too. Because 2 arguments is not bad. Oh! Okay, so we need that. Hold on. Let's write out the rest of the stuff. Event handler, buffer. Oh wait, event handler buffer, event handler buffer. Okay. So we do need this stuff. So last click time and last clicked element. And because we don't want this to rely on engine, we can't just like use the mouse API. So this does have to be passed in. But I think we only need it here. So it's like if we have one function with 3 arguments, whatever. Write event can take like lm buffer dot back lm okay, that doesn't be const. And also like const correctness, it's just like, okay, well, let's, you know, we know what we need. I think I'm okay with taking more arguments in this case. This we could just take and these are both size t's. If this needs like this isn't bad design to me. If this needs to change, we can change it. But if we create some like struct that requires a bunch of fields, that's harder to change. This is easier to change. It's easier to go from many arguments to few arguments. You know? It's easy to take this and put it into a context object. So it's just like it doesn't move me that much that we have a bunch of arguments. Like, I don't think that's like anti-computer science. You know what I mean? Like, I think we're fine. Okay, so we have handle events. That gets called here. Handle events. And we pass in UI dot what are our arguments? Event we don't have an event handler buffer. Oh, it's called the callback buffer. Right. I was gonna say we already had this working. UI.lm buffer UI.last clicked time UI.last clicked lm. Okay. I just want to use the same name everywhere. So this like, it should be clear of what's happening. So what system does this belong to? This belongs to like an element system. This is sort of like update element state. Does it, like, or process. What's the OpenGL thing, right? When it's like, or what's the guy like process or poll events? We're not like polling events. And then processing input. But I mean, because it's going to be more than just updating element state, right? Well, I don't know. If we type on the keyboard, that might even be a different thing. So let's call it what it is. Let's call it update element state. I don't want to put it in. We could just call it update elements. But that's kind of vague. Process. I don't know. Let's just call it element. I don't know. I'm just going to call it element system. Whatever. My brain's a little fried right now. Alright. Pragma 1's namespace. Tie UI v3. Oh. Like I said, I auto update element. Actually, you know what? I'm not gonna save delete. I just created the file. I'm gonna do something like this. I'm gonna say, where's context? I'm gonna put this in context because it's sort of like std vector element lm buffer and then quad tree. Let me get rid of that, get rid of that, get rid of that, get rid of that. This now you might say, oh, James, you're being lazy. Bear with me. Update element state UI dot lm buffer UI dot quad tree. I think it's important at this stage to know what these functions require. We should really only be using 2 buffers tops per function. And the reason is because we're iterating over stuff. So this is going to be 2 buffers. This is 2 buffers. These are just size t's. This is 2 buffers. This is 2 buffers. Like, you should be able to see, okay, these are the things, these are the lines of memory that we need to access step by step. I think that's going to help me confirm that this is a good design or not a good design. This is a bit different, but again, it's almost like maybe like some of the stuff like we're gonna want to like pass in some stuff. So we'll see. 1 second. Let's put this stuff into context too. Let's say update quad tree, inline auto update quad tree, which we need a stood vector of quads, and a quad tree. Let's call it fill quad tree. And we can say quad tree dot clear, and then we could say it's just the out buffer, right? Quads dot size, quad tree dot insert, quad, and then its index. This is from, this is to. Okay. So we have fill quad tree with UI.solve context.out buffer and then UI.quad tree. Okay. We could say inline auto consolidate quads. Do we want to call it consolidate quads, or do we want to be more specific, like remove layout quads? We could do, let's say remove layout quads, because like that's just going to be like, okay, what's this doing? Oh, right, it's removing, like, why are we consolidating? Okay, we're doing this. Again, none of this stuff is user facing. So we need quad indexes, which is what? That's a vector of size t. All right, so stood vector okay, so we'll go from, we'll iterate over this, and we'll take temp quads we'll we'll say temp quads dot clear, because let's say we want these functions to sort of like be called whenever. Temp quads gets cleared. Does not mean it's removing memory. And then we're gonna swap quads with temp quads. And so like this, we'll take a const ref to that. Okay, this to me is sort of like, maybe this can be optimized, but at least it's like pretty clear like what is actually happening here. Like these are pretty like straightforward like little functions. And so this gets remove layout quads, and what do we take? UI.lm quad indexes, UI.solve context.out buffer, UI.solve context.out buffer temp. Okay. So this style and then render. Okay, so these are the steps that we don't have done. We need to do style here. We need to do some sort of style compilation there. But overall, you build a layout. So you build the layout, and then what do? You probably say something like, oh right, so this, we're probably going to want to pass it in like that. You probably say something like, auto commit layout, or like you describe your layout. There's no like build layout, like commit layout. Done. Okay, how do we do that? Well, we use these three functions. Okay, render loop, maybe this happens, but anytime you update the layout, you commit the layout. Okay. We could say like inline auto update. And then we could have like inline auto render. So then this responsibility goes there. This responsibility goes here. We can say to do add clear layout function or a reset function if necessary. This might not even be necessary, but I'm just putting it there just in case I forget. I don't think I will. And so I can take this out. Okay. All right. Let's look at this. And then I'll end the video because this is actually a really good stopping point. Let's see what this is doing. Okay. So we're creating a box, and its quad is going to be this is the shape. So we're going to say starts in, left is 5, top is 10. We go downward like most UI. So it's like, upper left origin, ULO. It expands to its contents width and its contents height. The layout direction is down. So its contents width is going to be its max child width, and its height is going to be the sum of its children's heights. Okay. Style doesn't do anything yet because we're not actually rendering anything. Okay. On mouse enter. On mouse enter, we print out yay. Okay. Children. We list some children. Okay, so we begin and then we say, okay, we want to create, let's say, just to test it out so we don't have to go through 1,000 different things. We create 2 boxes within a loop. This is a little clunky, but whatever. The point is to demonstrate you can embed any sort of like immediately evaluated logic inside a child or a children sort of list, as long as it's an element writer type. And we probably want to change this to like, element writer, element builder, It's not like the builder actually does anything or maintains any state. Food for thought. Not really sure exactly the best way to do that, but I don't want to add macros, and this is like pretty clean without macros. Then we had another child that's 50-30. So we're going to have 3 children, and 2 of them are going to be 60-20. One of them is going to be 50-30. They're just going to follow the layout. We're going to commit it. And then in update, I think what we're going to do... Okay, this is where we would actually take in... Let's change this. Let's say... sorry, not stood. GLM vec2 mouse pose. And let's say we query mouse pose. And this way, and then we go to our API, mouse pose, and then this, we actually are responsible for passing this in from outside of the API. So this is sort of like, you gotta like use Tide engine or some sort of way to like get the mouse position, but like we don't handle that. Update. Okay, now we're gonna pass a mouse position in that's inside of this parent box, so we should hit this, and we're gonna we're gonna test. We're gonna render 10 frames. I mean, we're not actually rendering, but we're gonna go for 10 frames. This should only get called once, and then we're gonna be here. Okay. There's a chance that some of the CMake stuff hasn't updated. I don't know even if we need this file. We don't. Okay. Yeah, I just want to be clear. This is all you need to render. Okay. Oh shit. We're gonna have to do V1. Did I get rid of element system? Yes, I did. Will it load? Okay, it'll load. All right, let's run it. Now, okay. Include util. Okay. Okay. All right, something broke. Okay, that should be UN16. Are we using UN8 anywhere else? Let's try that again. I don't know why that would have crashed, though. It could read a UN8 from... Well, let's see. Okay, so it called that. Let's see if it calls it again. Nope. Okay, so now we're done. All right, so our out buffer, okay, so right, so our layouts are done for. Okay, left, right, width, height. Okay, let's see if this math adds up, because we are moving down, right? Yeah, we are moving down. Our second one is going to be 60-20 at the top left. We're going to move down the height. It's going to be 60-20. We're going to move down this height to be at 50. Top plus height should be 80. But this says height is 70. Oh, the height is 70. Cause if we're offset 10 from the top, it should be 20 plus 20 is 30, 70. Okay. So it works. It works. It works in this one particular test case. I haven't now there's a lot more to test. But I'm pretty happy about this. Now, where do we go from here? Okay, well, flesh out the operation constraint API. Take anything that is relied on V2, bring it into V3, or just copy it. Better yet. And well, actually, let's do styles next. Let's not put this off anymore. Let's do styles and then let's do rendering. How about that? Because man, but this is, I mean, oh man, this is really nice. I'm pretty excited about this. Cause if you think about it, yeah, this is a lot of code for a little bit of stuff, but it's very declarative and simple, and you can create presets for a lot of this stuff. Like, you could say, yeah, you could have some sort of, yeah, you could create presets. You could have some function that calls these other functions for you. You could, there's a lot of ways that we can simplify this. You just put this right in here. You can pass a pointer to some other function if you don't want to create a lambda on the fly. This stuff is going to be the default. This is going to be the default. This is going to be easy to enact. This I'm pretty excited about. This is pretty simple. Yeah, I think next stop is to get something on the screen, because, and then probably do text, and then probably think about widgets. Okay, so we're not done with V3. We're not done with V3, but this to me feels like V2 API with easier construction. Definitely less steps. And like the commas with, like, before it'd be like that, and then like you'd be left, and then top would be indented. Like, it's stuff like that drives me crazy, where it's just like, all right, just take, whatever. But then like choosing to do the curly braces for children, where it's like, okay, that's purely a style thing. We could get away with taking, a template argument or whatever, but then maybe that would even be faster. It probably would, because in an initializer list, you might have to heap allocate. I'm not really sure. We're not allocating a lot, but I mean, we'll figure something out. We can write our own data structure that might write to like some buffer that takes an arbitrary number of arguments. That's actually probably what we should do, because we should probably say, instead of taking an initializer list, take like, because an initializer list, oh, that's the song. Anything invalid here? Nope. Okay. What was I gonna? Stood initializer list. Like, I don't really know much about initializer list. Lightweight proxy object. I don't know. I'm not gonna try to like sidestep initializer list. Again, this is not something that's really done in a hot path. Well, it might. I don't know. This I'm happy. I'm happy with this. I'm actually really into this. I think overall I'm very proud of where this is going. This feels really clean to me, and I know I can make it cleaner. And it feels really good knowing that like the back end is also pretty clean. This is it. Just include API. And it's not like it's like, oh, it's like API actually does shit. API is the public facing API, but this stuff doesn't actually use it. Okay. That's enough. I'll end it here. Bye.